Okay, ji, assalamu alaikum to all attendees. Today we are having our last session for this semester, right? Week number 16, lecture number 2. So we are left with one small topic that will conclude maybe in half an hour, right? And then maybe we can discuss things if you have any, right? So today basically what we have to see, we have already seen many examples from writing data to files, reading data to from files, and so on, right? Now you can manipulate those functions and you can come up with any innovative programs that you can think of. Okay, so today basically what we'll be looking at is more related to streams rather than file. Okay, and more specifically we'll be talking about these operators, right? Stream insertion and stream extraction operators, right, which you use with C in and C out. Okay, so you see, from your day one of programming, maybe you are told that if you have to display something, you write something like this. Okay, and if you want to get user input, then you have to do something like this. Okay, so this we have been doing from the very first day when you might have written your first program. Okay, but you see, when we move to object-oriented programming, and we said, unfortunately, you cannot do this. Okay, means you are not allowed to use cin and cout with your own data types. Okay, so with built-in data types, you are free to use, but if you have a structure or if you have a class or any of the data type that you have created, then these statements to display using cout or to get user input using cin will not work, right? So today we'll try to change this and we'll do something so that these become legal statements, right? In other words, we want to allow cin and cout with objects of your own classes, right? And I think in the middle of the semester, a few of the students asked this. So today is the time that you will actually see this. Okay, so you see it is very much similar to what we were doing in operator overloading. For example, you know that you can add two integers, but in order to add 2 points, okay, in order for this to be a legal statement, we had used operator overloading. It means without operator overloading, you cannot use plus or minus or any other relational or arithmetic operator with objects of your classes. But once we implemented operator overloading, we were able to do that. Similarly, the same concept we'll be using today. Okay, so I'll be going into more details. So let me just first explain how this is working for basic data types. Okay, so let me just write in text is something like this, and cout is this. Okay, now let's discuss what actually is this statement. When we were starting this topic, files and streams, I told you that this is actually an object. Okay, and object of which class? Object of OStream class. Okay, so this is an object, and what is this? This is a variable. Okay, it can be any basic data type, integer, float, character, string, or whatever it is. Okay, and now what is this? This is actually an operator. Okay, so you see, just like you write maybe a plus b, so this is your operand and this is your second operand. Okay, and this is your operator. Now if you compare this with cout, it is more or less similar, right? On the right side and on the left side, you have operands. Okay, so these blue things, they are actually your operands, and this is your operator. Okay, so this is an operator. On the left side, you have object, which is a variable, right? Object cout is an object of which class? OStream. And on the right side, you have an integer. In place of integer, of course, you are also allowed to have float or character or any other basic data type. So now you see, this is already legal statement, C out X, where X is an integer. What we are trying to do, we are trying to make this a legal statement where P is an object of a class. For our discussion, we say P is a point, but of course it can be any class, okay? So now if we want this to be a legal statement, then you can think that, okay, it means I need to overload this operator. And it is very much similar to what you did when you wanted to add 2 points or multiply or subtract them, right? That since we cannot use operators with objects of our classes, so when we want to use some operator, we do operator overloading. So it is very much similar. The only thing is that previously maybe you did not consider this as an operator, right? But this actually is an operator. You have something on the left, something on the right. So if you want to allow it on objects of your own classes, then you will have to overload this operator. Okay, so the first thing is that we need to overload this operator. Okay, and the next thing is that we say, okay, how can I do operator overloading? Okay, if you remember, let me just gain some space and then I write. When you were adding 2 points or you were adding 2 vectors or doing anything else, we said there are different ways you can overload an operator. You can overload an operator using a member function, means it is in the class, okay? And you can overload using non-member function. And if it's a non-member function, it can also be a friend function so that you don't have to call get and set functions and you can directly access data using dot operator, right? Okay, so now let's see, suppose I have 2 points, point P1 and P2. And when I write P1 plus P2, okay, and I overload it using a member function. So when you do operator overloading in the member function, what you do, you will make a function. The name of the function would be operator plus. Okay, it will take 1 point as an input. Whatever is on the right side, it goes as an input. And whatever is on the left side, the function is called for that object, right? If you remember, this is from operator overloading. So I'm just giving you a recap that when you are doing operator overloading using a member function, whatever argument or operand you have on the right side, it goes as an argument to the function. In this case, for example, P2 is passed as an input to the function. And whatever is on the left side, the function is called for that object, right? And we also saw that you can also overload an operator like this, where on the left side you have point, on the right side you have an integer. So what will happen that instead of point here, then I will have to write int, okay, because I will make the function in point class and 2 will be passed as an argument, right? So this was just a recap with plus operator so that you remember how we were doing operator overloading. Now coming back to what we have to do today. Okay, now you see, if I just write, this is what we want to do today. C out P. Okay, P is point, C out is object of O string. So now if I want to overload this operator, what would be the name of the function? The name of the function would be operator. Okay, and whatever is on the right side, you pass it as an argument. What is on the right side? Sorry, I missed the operator. Let me just correct it and then I write. So the name of the function would be this. The input to the function would be whatever is on the right side. What is on the right side? Point. Maybe something like that. Okay, let's forget about return type for the time being. Now, if I make this function, then in which class should I make this function? If you remember, I should make it in the class which is on the left side. What is on the left side? Cout. Cout is an object of which class? OStream. So if I want to overload an operator, this would be the name of the function. This would be input to the function. And where should I make this function? If I'm going for member function, this function should be made in the class whose object is on the left side. So on the left side, I have cout. Cout is an object of OStream. But you see, OStream class, did you write it or did I write it? No. OStream class is already available. When you install the compiler, you get it with C++ distribution. So you see, it does not make much sense that if we allow everyone to change the standard classes. It means if someone makes a function in this class, then everyone can add whatever they want to existing classes. So there will be no standard. That is why you are not allowed to change anything in the classes which are already there, which are provided with C++ distribution. Yes, you can make your own classes, you can do whatever you want, but you cannot change the standard classes of C++, right? So it means I cannot add a function to OStream class. If I cannot add a function, it is actually telling me I cannot do overload this operator using member function. Okay, so it is important to understand why we cannot overload this operator with a member function. The reason is that when we do operator overloading using a member function, we have to make that function in the object or in the class which is on the left side of the operator. In this case, on the left side, I have cout, and the cout is an object of OStream. So if I want to do operator overloading with member function, I will have to make this function in the OStream class. But OStream class is a standard C++ class. I am not allowed to change it. That is why I cannot overload this operator with a member function, right? So before I move on, if anyone has confusion, because this is a slightly tricky topic, so I'll take a pause. If you do not understand that why we cannot do operator overloading with member function, please let me know. Only then I'll move forward, right? So please tell me if you have any problem in the discussion so far. Okay, so in our discussion so far, we have identified 2 points. The first point is, as you can see on the left corner of your screen, we need to overload this operator if we want to allow cout with objects of our classes. And the second point we discussed is that we cannot overload this operator using a member function. And the reason was that if I make a member function, I will have to make it in the OStream class, but OStream class is, we are not allowed to change it, right? So these are the 2 points that we concluded so far. Now let's move to the third point and see that now what we can do. Okay, so what are the choices left with us? We can do it with a non-member function. That is the only choice. And if we are doing it with a non-member function, of course, if we want to make our life easy, we can make it a friend. Even if we don't make it a friend, it will still work, right? It's your choice. Anyways, so the third, when you say cannot do with member function, you are actually saying that do it with a non-member function. Okay. Now let's recall how we do with the non-member function. If a and b are 2 points, and I want to overload plus operator, I make a function operator. Okay, plus, and since it is a non-member function, so the number of inputs is same as number of operands. So if you are adding 2 things, there are 2 inputs, okay, and it will be returning a point, and then you can write body of this function. Okay, so it means when you are doing operator overloading with a non-member function, you pass both what is on the left as well as what is on the right. Okay, now based on this, I'll not erase it, just see what is here. Okay, let me write something here. So we are overloading this operator, so name of the function would be operator and this. Okay, now what are the arguments of this function? The first argument is what is on the left side. The second argument is what is on the right side. So on the left side, what do we have? Cout. What is the data type of cout? Cout is an object of OStream class. So this is the first argument. What is the second argument? On the right side, we have point. The second argument would be something like this. Okay, and of course, for the time being, I'm writing void here. Okay, because this is the first example. Later, we'll change this as well. So for the time being, let's forget about the return type. Okay, so here maybe I can write some variable name like s and say p. Okay. Now let's discuss how this function will be called. Okay, so let me just gain some space. Okay, so I'll just be making an object of class point and I'll be trying to call this. Okay, so you see, I'll write say point P, which is 2, 3. Okay, and then I'll be writing something like C out P. Okay, so when I write this, what will happen? This function will be called, and this C out will go into this S. Okay, the first argument goes to the first variable, and this P will go into this P. Okay, now it means what I can write in this function. Since I want this function to display X and Y coordinate of the point, so here you can write C out, but you can also write S, right? Because S and C out are the same thing. But before I write the body of this function, there is one important slight change which I need to make to this function. And what is that change? You see, when you are making a function like this, if you remember what is this, this is called call by value. What happens in call by value? A copy of data is made, means this P is a copy of the P that you are passing from the main, and this S is a copy of C out, right? The second one is okay, there's no problem, but there's a slight problem with the first one. The reason is that we are not allowed to make a copy of C out. And why is it that? You see, if they allow copy of C out, it means in the main someone can write something like this: O stream O is equal to C out. Okay, and then someone would be writing this. Okay, which will be deviating from the standard. They want that you only use C out and C in as object. Okay, so that they are standard statements for printing data or for you can say getting input from the user. So in short, the third important point is we cannot make copy of C out. Okay, means I cannot take another variable and copy C out in it. Okay, and but when we are passing something to a function, we know it is call by value, and in call by value, a copy of data is made. So in order to avoid that, we have a solution. And what is that solution? That solution is call by reference. When you put this symbol here, it is call by reference. And in call by reference, what happens? No copy of data is made. C out and S, they are actually the same thing. Okay, so this is call by reference, which we had seen in the very beginning of the semester. And I'm sure you also had seen it in the previous semester. Okay, so the third important point is, since we are not allowed to make a copy of C out, so when we make the function, and this argument is passed by reference rather than by value. Now within this function, what you can do, you can use S or you can use C out. Both are okay. And you can write P dot get X, which will give you 2. And then you can write P dot get Y. So you see, now this statement is actually a legal statement and it is working like the print function. Okay, you used to make a print function, but instead of making a print or a display function, if you overload this operator, you will be able to display the data members of a class just like you display an integer. You just write C out this operator and object, so all the data will be displayed, right? This is the point, but of course you can overload it for student or employee or anything else, right? And another important point is that you see, since this function is a non-member function, okay, so it means I have to call get X and get Y because X and Y are private. But if you make this function a friend of point class, then instead of these two, you can also write directly P dot X and P dot Y. Okay, so it's your choice. If you want to make friend, you will not have to use get functions, right? Let me first make this program, show you the output, okay, and then we'll discuss further, because there is one small thing that we ignored, which is this one, but I will do it later. First, let's write a program so that you are convinced that this actually works, and then we'll discuss it further, okay? So this is a compiler. I already have the point class from yesterday, okay? This is the point class xy constructor display and get function. Let me run it to see if it is fine, and then I will add things to it. Okay, yeah, it's working. Okay, so now what we do, um, we uh, we overload this operator. So I write void. What is the name of function? Operator and this symbol. This is name of the function. Okay. What are the two arguments of this function? The first argument is poststream. Okay, and I told you that since we cannot make a copy of cout, that's why we are passing it by reference. The second argument is point p. Okay. And within this, what do we write? We write as p dot get x, and similarly we write as p dot get y. Right. So what you are doing, you are simply printing two integers x and y in this function. Okay. If your data is like some other class, student or anything, you can print all the data members. Okay. And now in the main, what we can do, we can say make an object of class point, say point p23, and now we can write something like this, cout p. Okay. So now this would be a legal statement. Although this function is not complete yet, right? There are some slight modifications that we still need to do. But as a first starting point, this should give you a general idea of how things are working. Okay. So for the time being, we just have overloaded this function. Within this function, we are printing x and y, which are data members, and you see we have the output 2, 3. If you see at the bottom of the screen, now this is a legal statement which is calling this function. And what is this function doing? It is printing the data member. So you can see the output, which is 2, 3. Okay, we are having the output. Now, as I told you, that instead of using get x, get y, if you make this function a friend of the class, you can directly write p.x, p.y. Okay, so if you want, how do we make function a friend of the class? We simply copy the prototype of the function, we paste it in the class, and we write the keyword friend. Now, this function is a friend of class point. So instead of using p.getx, now I should be allowed to use p.x and p.y directly. Why? Because a friend function is allowed to access the private data of the class, right? So once you make it a friend function, even if you don't do it, you saw the program is still working fine. I showed you the output, right? But since you will have many data members in a real class, so rather than calling get methods, when you are overloading the operator, it's a good idea that you make the function a friend of the class. So you see, now you again have the output, but this time instead of using p.getx and get y, I'm directly writing p.x, p.y, and it is working. Okay, so this is one basic example, right? We still have to extend it as I told you, but if till now, if you have any queries, we can discuss those before moving further. Right? Thank you. Okay, you see now we simply made an we simply overloaded the operator and we were able to run this. Okay, and you can do it for any other class. Okay, now let's get back to some more details. Uh, when you are dealing with basic data types, like for example, you have integer a and integer b, so you are also allowed to write something like this. Okay, that within a single statement, you are allowed to print multiple variables. For example, this will print A and B. So rather than having two separate statements, cout A, cout B, I can combine them in a single statement, right? Okay, now let's see how this is happening. So in order to understand this, maybe we take another example. Suppose I write D is A plus B plus C. Let's discuss from plus operator, right? Because plus operator is very easy to understand. We have been working with it since our childhood, so it is easy to understand. When you are adding, so you see all three are not added together. What happens? Since it is the same operator, the precedence is same, so you operate it, you work it left to right. So first you will add A and B. Okay, what will happen? A and B are added, you get an integer as a result, and then whatever is returned by A plus B, which is again some temporary integer, that is added to C. and then that is added to C, so you get the final answer which goes into D. Okay, so when you have multiple operations in a single statement, they are not all executed at once. They are executed stepwise, right? Just like I explained you that first A plus B will be performed. Whatever answer you get, that answer is added to C, and then you get the final answer, right? So it is a stepwise process. It is not everything is happening in a single step. Now keep this in mind, and now let's come here, yes, with the C out. So you see, when you have this operator twice, it is just like having 2 plus together. So you see, this is not executed in a single step. It is executed from left to right. So first, what will happen? What I have highlighted in blue, first this is executed, C out A. When you execute C out A, what happens? The value of A is printed on the screen. So 5 is printed on the screen. And then it must return something and then execute it further. Okay, because this is leftover, this symbol and B, and this part is executed, it will return something, and then the next part, which is this symbol and B, it will be executed. So now you should think, what should it return so that it becomes a legal statement? You see, the only thing that this blue box can return, it should return C out, because if I put anything other than C out here, this statement will not be legal. This statement is only legal if I have C out here. Okay, so when you execute the first part, C out A, 5 is printed and it will return C out. When it returns C out, now you see this is again a legal statement, C out B, and then this is executed. So you see 10 on the screen. It might be a bit difficult to understand, but you can understand it by looking at this plus example. Okay, that first A and B are added, they are returning an integer. And then that integer is added to C, so you get another integer, which is your answer, which goes to D. Similarly, when I'm writing C out AB, first C out A is executed, 5 is printed on the screen, and then you see now you are left with this part, this symbol and B. So you can easily guess that what should I put here in this blank so that it is a legal statement. The only thing you can put here is C out, because if you put anything else, this statement will be illegal. Okay, because the only thing that can come in this blank is C out, which is actually telling you that when this is executed, it is actually returning you C out. And since it is returning C out, this is the reason we can print multiple variables in a single statement. If this is not returning anything, then what will happen? This will execute, you don't have anything here, and your statement would be B, which is illegal. So in that case, if the C++ compiler was not doing that, you would not have been able to print multiple variables in a single line. So now you see, if we want to implement the same thing in our program, let's go get back to our program and see whether our program can do this or not. So you see, what is the return type of our program here? It is void. Okay, it is void, which means that when I will write this is okay, this is working, you are convinced, you have seen the output. But will this work if I write C out? Will this work if we try to answer this question? No, this will not work. Why this will not work? You see, because when you write C out P1, this is first, this part is executed. When this part is executed, this function is called. Okay, this function is called, it will print x coordinate of P1, it will print y coordinate of P1, but it is not returning anything. So it means nothing is returned here. When nothing is returned here, you are left with this. Nothing, this symbol P2, which does not make sense. It is not a legal statement, right? So if I try and print 2 points in a single statement, then I cannot do it. This is the handicap in this current version. Okay, and just to show you that this actually is not allowed, let me try change this program, take another point, say point P2, which is 4, 5, and let's call it P1. Okay, so when I only write C out P1, then we discussed that it should work. So it should print 2, 3 on the screen. Okay, so let me run this and see whether it's working or not. Yes, it is working. 2, 3 is printed on the screen. You can see the output. Okay, Now let's say, okay, I'm a bit over ambitious and I say, why not print P1, P2 both in a single statement? And now when I try to run it, okay, so you see it will not work. It is giving me an error. Why it is giving me an error? It is saying void endpoint. Okay, now what does that mean? It means that when I executed this function, cout P1, P2, since my return type is void, so when this is executed, I have void, means nothing here. So it becomes void P2. You see, this does not make sense. Void this P2. Void means nothing. So that's why this is not working. So if you need to make this work, all you need to do is change the return type. And how do we change? Actually, whatever is coming as an input, you send it back as an output, right? Because we want cout. We want this whole statement to return cout so that the next statement could be executed. So it's fairly simple. Whatever is coming as an input, you simply return that. Okay. So I'll simply copy this O stream by reference. Instead of void, I'm writing this. Okay. So whatever was coming as an input, which was S, I say return S. That's it. And of course, I also need to do it, change it in the statement where I'm making it friend. So you see this part might be a slightly tricky, but just remember what is coming as an input, you are sending it back so that you can print multiple objects with a single statement. Now with this change, you see what will happen. Now both the points are printed. You see I have written only one statement, cout P1, P2, and 2, 3 is printed, 4, 5 is also printed. Okay, so maybe I can just change this print function. So one point is printed on the same line, so it will be easier to follow. So instead of having two different lines, yeah. So now you see one point will be printed on a single line. So you can see 2, 3 is printed and 4, 5 is printed. You see why? So now you can have as many objects as you want in a single statement. If the return type is void, then you would not be able to do that, right? So this is now complete in the sense that now we have a complete function which works very much in the same way as it works for basic data type. You can print objects of any class and you can print multiple objects with a single statement, right? So now if you have any comments or queries, we can discuss those, and then we'll quickly write a very similar function for input as well. Okay, now I'll change this program to allow cin. And you see now, once you have all this information available, for cin, you see cin is an object of istream, input stream. Okay, so what we'll do, in exactly the same function, I will copy paste. Okay, and I will replace the symbol and I will replace O stream with I stream. Okay, and because scene is an object of I stream. So let me just tell you what I'm trying to do. Now we also want that user should be able to do this. When we write scene P, then user should be allowed to enter values, means enter X, enter Y, and they go to this P. So just like we made cout P a legal statement, now we want to make cin P a legal statement. Now cin is an object of istream. So it means the first argument to the function would be istream and the second argument would be a point. Okay, and of course this has to be by reference. So these are the two arguments of the function. Here you will write name of the function, which is operator, and this symbol. You see, so it would be very similar to this one. But of course, in the body of the function, now we need to input. Okay, so instead of simply displaying the value, we will ask the user to enter values c in p.x, p.y, so they are copied in the p in the data members of the p. Okay, so I'm simply copying this and I have pasted it here. Okay, so the first thing I need to change is instead of O stream, I have I stream. Okay, rest everything stays the same. And I have also emptied the body of this function. Similarly, with cin, we do not use this operator. You have to reverse the direction of this operator. Now this is the operator. Okay. And maybe for the time being, I just write cout, this function is called. Okay, just to see whether things are working or not, and then I will call this, I will change it. Okay. And there's no harm in making this function a friend of the class. So I copy its prototype, I paste it here, and I make it a friend of the class, just like we did for OStreams, right? So if you see both of these statements, they are exactly the same. Operator is reversed because with cout you use this operator, with cin the operator is reversed, and the name of the class is changed. Rest everything remains the same. Okay. So now here, what I will do, I will say point p, and I will say cin p. So what should happen with this? When you write cin p, this function should be called. We have not done anything in the function yet, but first we want to be sure that yes, this function is actually called. So you see the output, this function is called. That was just to convince you that whenever you will use this operator, this function will be called. Now, we don't want to print this thing. We want to do something else. So whatever you want to do with cin, you can do it in this function, right? Because now we have seen that this function is being called. So uh, this is not 100% correct, but let me write it and then maybe I will ask you what is the problem. Okay. So in this function, we want to enter x and y. So I'm writing enter x, and you can write cin p dot x, that is okay. And you can also write s, because s and cin are the same thing. Okay, when you call this function, cin and s, they are both referring to the same thing. And similarly, you can write enter y, s p dot y. Okay, there's a problem with this function. Okay, but I want you to figure it out. Okay, now what will happen when I call this function? Cin is s, this p is in the p which is in the function. We are asking the user to enter x and y. User will enter two values. Okay, and we expect them to be the x and y of p. So let's also, okay, not let me just see, run it, and then we'll discuss further. Okay, so you see now that function is called. I'm entering x, which is 2. I'm entering y, which is 3. Okay, and then the program terminates. Okay, now let's also print and see whether the values we have entered, they are going in p or not. Actually, they will not. Let me show you the output. And so I enter 2, I enter 3, but you see when you print the data, you are getting 0 0, which should not be like that. We enter 2 and 3, but we are getting 0 0, right? So I want you to think over it. Why is it happening? You already know the answer, but you just have to be careful. You see why is it happening? It is happening because let me just take the pen. When you call this function, this cin is s by reference. This p goes to this p, but the second argument is by value, right? So you have a p in the main and you have a p in the function. When you see in 2 and 3, they are in x and y of this p, which is local. And when the function terminates, this is lost. And in the default constructor, the value was 0 0. So that's why when you write cout p, you see 0 0 on the screen. What is the reason? Because the second argument that you are passing, it is by value. That's why whatever you are entering, that is not going to the p which is in the main. Okay, this is the same discussion of call by value and call by reference that we did when we were studying function. So it is actually suggesting that in case of cin, the second argument must also be by reference. Okay, if it is not by reference, sorry, I have to change in this one, where it is entering data, and as well as in the function prototype where I'm making it a friend of the class. So now if you will enter any values, since we are passing point by reference, so whatever you enter in the function, those values are actually going to the variable p which is in the main, right? So now you see when I enter 2 3 and I write cout p, now I am getting the correct values 2 3. Previously I was getting 0 0. Why? Because I was not passing point by reference. So the values which we were entering in the function, they were not going to the variable which was in the main, right? So you have to be careful that the functions are exactly the same for cin and cout, but the slight difference is that when you are using cin, you also have to pass the second argument by reference, so that whatever values you are entering in the function, they are actually changing the variable which is in the main, which we saw in detail when we were looking at call by value and call by reference, right? So these were the two functions. Now you can use it with any class. Instead of point, you have student, employee, so you just, instead of point, you write student here, and in this you can print all data of student, and in this you can enter or input all data for student, right? So this is something very useful. Again, as I told you, just like with operator overloading, you can live happily without these operators as well, right? You can write p dot input instead of writing c in p, and you can write p dot print instead of writing c out p. But the motivation is same as that of operator overloading, right? That you can add 2 points by making a function p1 dot add p2, but you said no, maybe I will write p1 plus p2, so that I'm using my convention is same what I have for basic data type. So the motivation is same. Okay, you see, even if you are not doing any operator overloading, you can still write a program. There is no need of cin because you can make an input function. There is no need of cout because you can make a print function. But as we discussed, in case of operator overloading, the motivation is that we want to be able to use the operators with objects of our classes, just like we do with basic data type, right? Otherwise, it's not a compulsion. Of course, when you are writing big program, as I keep telling you, it's a good idea that you overload these operators, so that whenever you see this or anyone sees your program, they would instantly know that you are getting input for this object or you are printing this object, right? So with that, I'll stop. If you have some comments on this, we can discuss those.